Good day everyone. My name is Acosta from BSCS 4A. So in today's video, I'll be reporting the file system implementation. File system implementation. File system implementation defines how files and directories are stored, how this space is managed, and how to make everything work efficiently and reliably. Boot block. When the computer is booted, the BIOS reads in and executes the MPR. The first thing the MPR program does is locate the active partition, read in its first block, which is called the boot block, and execute it. The program in the boot block loads the operating system contained in that partition. Every partition contains a boot block at the beginning, though it does not contain a bootable operating system. Superblock. It contains all the key parameters about the file system and is read into memory when the computer is booted or the file system is first touched. Implementing files. Contiguous allocation. Each file is stored as a contiguous run of these blocks. Example, on a disk with 1 kilobyte blocks, a 50 kilobyte file would be allocated 50 consecutive blocks. With 2 kilobyte blocks, it would be 25 consecutive blocks. Each file begins at the start of a new block, so that if file A is occupying 3½ blocks, some space is wasted at the end of the last block. So advantages is simple to implement. The read performance is excellent because the entire file can be read from the disk in a single operation. Drawbacks. Over the course of time, the disks become fragmented. Linked list allocation. The second method for storing files is to keep each one as a linked list of these blocks. The first word of each block is used as a pointer to the next one. The rest of the block is for data. Unlike contiguous allocation, no space is lost in this fragmentation. Random access of a file is very slow. Linked list allocation using a table in memory. The disadvantages of linked lists can be overcome by taking the pointer word from each disk block and putting it in a table in memory. Such a table in main memory is called a FAT, File Allocation Table. Using FAT random access can be made much easier. The primary disadvantages of this method is that the entire table must be in the memory all the time to make it work. Inodes. Inode is a data structure which is used to identify which block belongs to which file. It contains the attribute and disk addresses of the file's block. Unlike the in-memory table, the inode need to be in memory only when the corresponding file is open. Implementing directories. The main function of the directory system is to map the ASCII name of the file into the information needed to locate the data. A directory can be designed in two ways. In a simple design, a directory consists of a list of fixed size entries, one per file, containing a fixed length file name, a structure of the file attributes, and one or more disk addresses telling where the disk blocks are. For systems that use inodes, another possibility for storing the attributes is in the inodes, rather than in the directory entries. In that case, the directory entry can be shorter, just a file name and an inode number. File system organized in many layers. I/O control level. Device drivers acts as interface between devices and OS. They help to transfer data between disk and main memory. It takes block number, a input, and as output, it gives low-level hardware-specific instructions. Basic file system. It issues general commands to the device driver to read and write physical blocks on disk. It manages the memory buffers and caches. A block-in buffer can hold the contents of the disk block, and cache stores frequently used file system metadata. File organization module. It has information about files, location of files, and their logical and physical blocks. Physical blocks do not match with logical numbers of logical block numbered from 0 to n. It also has a free space which tracks unallocated blocks. Logical file system. It manages metadata information about a file. Example includes all details about a file except the actual contents of file. It also maintains file control blocks. File control block has information about a file, owner, size, permissions, location of file contents. You can implement file system by using two types data structures. The first one is directory structure. They store file names and associated inode numbers. In Unix, include files names and associated file names, and in NTFS, it is stored in master file table. The second one is per file FCB. It contains details about files and it has a unique identifier number to allow association with directory entry. In NTFS, it is stored in master file table. So that's all. Thank you.